Okay, let's see how we can draw the graph for the last function. This function looks complex. However, every complex function is derived from simple functions. So we should start from simple functions, then gradually extend it, make adaptations so that the simple function will be transformed into a more complex function. Okay, so let's first draw it on Desmos. So this is Desmos. Right now, you just see this red curve. This belongs to this function. Our original function is this one. However, we just choose part of this complex function so that we can see how a simple function derived into a more and more complex function step by step. I start from this function because on our first question on the lecture notes, we did a very similar question with it already. So if you do not know how to draw graphs about this simple function, please review the video about our first functions graph. Okay, so I just assume you know this. If you do not know, please go back to our today's class recording to see how to draw this one. Okay, so once we get to here, you can see the next thing I added to this simple function is the negative sign. What if I add a negative sign to it? Okay, as you can imagine, what previously was the positive values, then switch to negative values. Previously, the negative values, if you add a negative sign to the front or multiply negative one to the front, they switch to the positive values. Okay, you just switch the functions graph. Okay, positive turn out to be negative, negative turn out to be positive. All other amplitude are still the same, periods are still the same. Okay, I click on this button. You see this new blue line appears. Originally, it attains its maximum here. Now the maximum turns out to be negative, which goes to be a minimum. As it goes down, you see this blue line goes down while this red line is going up. Just flip it. And when this red line attains maximum here, the blue line attains minimum here. And when the red line attains its minimum here, the blue line attains maximum here. Just flip it, okay? Just that simple. So once we get here, let's erase the red function. Okay, we just keep negative sign here, and we multiply it by 3 to see how the function would change. Okay, step by step. Click on it. Now you see a green line. Still the same function with the same period. However, now you see multiply by 3. The amplitude has changed. Previously, you attained maximum at 1. Now the maximum goes to 3. Okay, the maximum is 3. Previously, your minimum is negative 1. Now your minimum is negative 3. Okay, so how about let's erase the blue line and see how the green line change into our final form. If you click on it, wow, you see a purple line. So how would add these two affect this blue line? You see, they're still the same period. However, the green line was moved up by 2 units, okay? Because you are adding 2, everything just moved up. Originally, you attains maximum at 3. Since you are adding 2, 3 goes to 5. Look, it's 5 here. Originally, your minimum is -3. However, since you are adding 2, this minimum turns out to be -1, okay? Because you're adding 2 to the -3, so it's getting up by 2 units. Okay, all other things are still the same, just moving up 2 lines. Okay, so let's erase the green line to see our final form clearly. So this should be our final graph. Okay, so we finished drawing it on Desmos. Let's see how we should do it on paper. Let me switch to my document camera. Okay, so now you see my document camera. Again, we should ask ourselves a few questions. What is the amplitude? What is the period? What is the shift? Since we are multiplying with 3, so amplitude is still 3. And we are multiplying x with 2, okay? Just like we did for the first question, we are multiplying with x with 2. The amplitude, the period is 2 pi over this omega. And here omega is 2, divided by 2, which is pi. Then we should consider about shift. In order to know about the shift, we need to factor these 2 out. You see, as I factor the 2 out, originally we have pi here. Now, since we are putting everything in a process and factor 2 out, the pi turns out to be pi over 2. And you see a plus sign here. So plus means shift left by such amount, okay? Remember what we write down here. Shift right, shift left is here. Shift left by pi over 2. However, we see an additional part, and we just explained adding 2 is moving up. Moving up by 2 units. So let's just say adding 2 here. Okay. And we have one extra unit change, which you see a negative sign here. That's a big problem for us. So as I just explained, it just means switch. If you originally have positive, now you have negative. If you originally have negative, you have positive. Just switch. Think about my hand, switch. So again, let's figure out where the origin is. Originally, the origin starts from 0, since you are shifting left by pi over 2. Shifting left by pi over 2. you should find it starts from somewhere here. However, we're not only shifting left, we're also moving up by 2 units. So 2 is approximating here. So the origin starts from here. Okay. Then when you draw the curve, don't forget we have a negative sign. Originally, the sine graph goes up and down, right? Up and down, up and down. However, since we're switching the sign, this is moving down and up, down and up, down and up. Okay, just everything is switched down. How far should we go down? Amplitude is 3, so we should go down 3 units. But we are starting from 2, so the minimum you should go is -1. And where should we attain the -1? Period. Period is pi. Originally, we needed pi over 2 to attain maximum or minimum. However, since we're shrinking the period, because the period is right now is only half of that sign, you would only need a quarter pi, which is pi over 4, to attain minimum. So now you see the pi over 4 should be somewhere here. And the minimum point attained is somewhere here. So you're going down to pass through this point, and then go up to pass through this point. Then you are going up another pi over 2, another pi over 4 to attain maximum. And remember that our maximum has been moved up by 2 units, and the amplitude is already 3. So it can goes up to 5. So the maximum should be somewhere here. And when we go to pi over 2, what do you get? You complete the whole period. If you just have sine x, you would go to the origin. However, everything has moved up by 2 units. You're not going to the origin. You are going to 2, which is this point. This point is 2. Okay, so let's sketch one period going down, going up, reaching the maximum, then going down. Okay, this point 5 made it clear. This point is 2. The minimum here is -1. This point is pi over 2, pi over 2. This point is negative pi over 2. My printer does not work very well, so that's why I don't see it very clearly. I'm rewriting the numbers. Then we finish one period using all the information here, and don't forget about the negative sign. That's it.